Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So this is my third video on redox reaction. So we are talking about the definition of redox in terms of gain and loss of electron. Tapi kita akan fokus kepada transfer of electron at a distance. What does it mean by transfer of electron at a distance is the electron will be transferred from one point to another point. So we are actually talking about jarak lah. Okay, ada satu jarak yang elektron tu kena transfer. Okay, mari kita tengok eksperimen ni dulu ya. Okay, so this is the experiment that you have in your textbook where we are actually discussing again about oxidation and reduction in terms of electron transfer. But in this example, the electron transfer is called transfer of electron at a distance. The word distance there, it's because the electron will be transferred from one electrode to another electrode through a connecting wires. So in this case, the electrode is X and Y. So this is the X electrode, the one that I colored with red. Okay, this is electrode X. And then you have another electrode which I colored with the blue colored pen. So this is the Y electrode. So you have two electrodes there, but both are made from carbon. Okay, and then you have two solutions. The first one is iron 2 sulfate solution. So you have iron 2 sulfate, and also the second one is acidified potassium manganate solution. Okay, what does it mean by acidified here is that inside that solution we will add sulfuric acid to acidify the solution of potassium manganate. So this is the actual substance that we use, but we add sulfuric acid to increase the acidity. That's why the term there used as acidified potassium manganate solution. And then inside that U tube, so the U tube, because the tube is looking like a U shape, okay, the sulfuric acid, okay, is used to complete the circuit. At the same time, sulfuric acid will also separate the two solutions. Okay, now another thing that you have to recognize in this diagram is galvanometer. So what is galvanometer? Have you seen a galvanometer before? Okay, if you haven't seen a galvanometer before, so this is a picture of galvanometer. So dia ada huruf G in the center of the galvanometer. So usually we will connect the wires, okay, through this black and red area here, the negative and positive sign. So for your information, so this galvanometer is used to detect the movement of electron. Okay, means okay, there is two ways of the deflection of the galvanometer. The first one, it can deflect to the right. Okay, this is the deflection needle. So if the deflection needle deflect, okay, to the right, so it means that the electron is being transferred from the negative terminal to the positive terminal. So the electron transfer through the connecting wire from the left to the right. Okay, so this is the first case. Okay, the second case is when the deflection needle deflect from the right to the left, or from the center to the left, like this. Okay, what does it mean is, okay, when the deflection is from the center to the left, this means that the electron is actually moving from the positive side of the galvanometer to the left side of the galvanometer. So what you have to do is you have to change the side of the galvanometer, negative and positive terminal. In this solution, you have iron 2 sulfate. So FeSO4, okay, it will ionize to form iron 2 plus, or you can say iron 2 positive, and sulfate 2 negative, or ion sulfate 2 negative. Okay, this is the ionization equation. Okay, the ionization equation will show when a substance ionizes in water, what ion it will form inside that water solution ataupun inside that solution. Okay, so you have iron 2 plus and sulfate ion. So between these two ion, okay, so iron 2 plus is actually the one that we are focusing on. So this iron 2 plus will undergo oxidation reaction. Okay, why undergo oxidation reaction? Okay, as you all know, iron is metal. So iron exists as atom. Okay, dalam keadaan biasalah at room temperature, iron is atom. Okay, when iron change to iron 2 plus, it will release 2 electron. So this is iron 2 plus. Okay, this reaction, as you can see, okay, the atom lost electron. So there is loss of electron there. So this reaction is called oxidation reaction. Okay, so atom, it become ion by releasing 2 electron, the atom. Okay, after that, when we set up this setup of apparatus, okay, when you have the 2 electrolyte and you have the connecting wires together, okay, the iron 2 plus will eventually, okay, release another 1 electron to form iron 3 plus. So it will release another electron to form iron 3 plus. Kenapa? Why? Because ada condition yang membenarkan dia membebaskan ion. Okay, when we put the two solution together and then we connect it with a connecting wires and the circuit is complete. Okay, the ion have ability to release electron. Okay, because there is another ion that want to accept that electron. Okay, this is the case where the iron 2 plus will release another 1 electron. Okay, this iron 2 plus again will release, it will lose another electron and again undergo oxidation reaction. Okay, so iron 2 plus ni dia ada tendency untuk release another electron, so dia akan release 1 electron to form iron 3 plus. Okay, so sekarang ni kalau dia change to iron 2 plus, dia akan change color. Okay, daripada silver shiny metal, dia akan become green. Okay, greenish yellow solution. So as you can see inside that diagram just now, so the iron 2 plus is actually greenish. Usually kita akan kata greenish solution lah. And then after this reaction happen, it will change again, okay, the color of the solution from greenish to form a brown colored solution. So iron 3 plus is brown colored solution. Okay, when it change color, it means that it's release the atom release another electron to form iron 3 plus. So if you recognize rust, karat. So it is actually contain iron 3 plus. The color of rusting is brown color because rust contain iron 3 plus. Okay, so kalau kita tengok pada reaction ni, when we look at the U-tube just now, so what happened is that, okay, the iron 2 plus ion, this ion, okay, from Fe2 plus, it will change to Fe3 plus by releasing one electron. So this is actually loss of electron, the process of loss of electron. So the reaction is oxidation reaction. Okay, so iron 2 plus undergo oxidation reaction. So substance that undergo oxidation reaction, okay, the ion will be considered as the reducing agent. Okay, Ra means reducing agent. Okay, settle that part. The iron 2 plus change to iron 3 plus. Okay, so what happened when iron 2 plus change to iron 3 plus? The electron that released by the ion 2 plus, okay, ion 2 plus, okay, will be transferred through the connecting wires and then go inside the galvanometer and making the galvanometer deflect. Okay, and then it goes through the connecting wire again, and the electron will be accepted by Y electron. So what happened is that, okay, dekat bahagian Y tu, at Y electrode, a substance must be able to accept the electron released by iron 2 plus. So which ion can accept that electron? So we have to look at the formula of the solution that we use, which is potassium manganate solution. Okay, so let me finish this first. Okay, so iron 2 plus change to iron 3 plus. The electron will be transferred. Okay, transferred through the connecting wire. Okay, so bila dia dah transfer, ada ion lain yang kena terima elektron tersebut. Okay, which ion will accept this electron? So we look at the formula of the substance that being used in the Y electrode. So we are using potassium manganate. Okay, potassium manganate, when the substance ionized, it will form potassium and manganate ion. Okay, so which one have possibilities to accept electron? Okay, potassium will not accept electron because potassium is a reactive metal. It will always want to release electron and become positive ion. So potassium is so electropositive, so it will not accept the electron. So the one that accept electron will be manganate ion. So ini yang kita nak fokus. This is what we are focusing on. So what happened? Manganate, MnO4 minus, okay, in this reaction will change to manganese ion 2 positive. Okay, how do I know that? Okay, because you have to eventually know that manganate will change to manganese 2 plus. This is what you have to memorize lah. Okay, so during this reaction, okay, we have an acidified condition. That's why the half equation will contain hydrogen ion. Okay, hydrogen ion coming from the acidified condition of the solution. Okay, so acidified potassium manganate solution will supply the hydrogen ion. Okay, now during this reaction, so what happens is that, okay, this reaction will making the manganate to accept electron. Now we have to have full half equation for this reaction. So as you can see here, the oxygen inside manganate ion, we have 4 oxygen atom there. So the product form is actually a water molecule together with the manganese 2 positive ion. Okay. As you can see, when we have 4 oxygen atoms, so we have to form 4 water molecules. So I put in front of the water molecule 4. Okay, because 4 will times with oxygen to get the same amount of the reactant and product side. So ni kita separate kan eh. So this is the reactant part. Okay, this one is the product. Okay, now we have to determine how many hydrogen ion and how many electron being accepted during this reaction to form this compound. So how do we want to calculate how many hydrogen and how many electron that we have, okay, in order to produce the product? As you can see, we have 4 oxygen here, so we have 4 oxygen on the product side. And because 4 is in front of the water molecule, so 4 will times the hydrogen atom also. So hydrogen have 2, so you have 4 times 2, so you have to put 8 hydrogen ion. You have 8 hydrogen there. Okay, so 8 hydrogen ion means that you have 4 times 2 hydrogen in the water molecule. So then you have 8 hydrogen. Okay, now you have to determine how many electron that manganate ion accept during this reaction. So one of the method that we use is to calculate the total charge of the reactant and also the product. So as you can see, we are looking at the charge now. So manganese, okay, the one that I highlight there, manganese have negative charge, so -1, and then we have hydrogen with 8 positive charge. Okay, and then we let the electron unknown as unknown value, so we just put it as unknown value there. Okay, we don't know how many electron we are using, so you just calculate the total charge of the reactant. So it form -1 plus 8, so you will get +7 there. Okay, and then you calculate the product, total charge of the product. As you can see there, the manganese, okay, ada 2 plus, but water doesn't have any charge there. So you calculate +2 plus 0. So 0 is for the water molecule, so you will get +2. So as you can see here, the total charge of the reactant and product is not the same. So how can we make the total charge of the reactant and product same? So we have to add in electron, because electron is the negative charge. Okay, so from +7, we want to change it to +2. So how many electron required in order for you to change +7 to +2? So you actually need 5 electron. Okay, 5 electron means you are adding 5 times -1. Okay, because the electron charge is actually -1. So what happened is that, Okay, if I put this into an equation, so you put positive 7 plus negative 1 times 5, so we will get positive 2. So this is actually the number that we want to determine during the reaction. So how do I put this inside the half equation? So I just insert the electron, the total electron that will be added into the equation is 5. So you need 5 electron in order for you to make the total charge of the reactant and the product same. Okay, if you have problem understanding this, okay, it's okay, because eventually you will go through more and more half equation. Then you will see that the addition and loss of electron is actually very easy to understand. It's just that this thing is new, so you have to take some time to understand. It is normal. Okay, so now let me rephrase ataupun tulis semula. Okay, let me write again both half equation for the reaction. Okay, just now we have iron 2 plus change to iron 3 plus. Okay, and the ion release 1 electron. And then we have the manganese ion, MnO4 minus, accept 8 hydrogen ion and also 5 electron to form manganese 2 plus ataupun 2 positive and 8 water molecule. So that is the half equation. This is what we call half equation. Okay, half equation for the reaction. Okay, this is at the X electrode. Manganese ion accept electron at Y electron. Okay, Y electron. Okay, so what happened is that when iron 2 plus release the electron will be accepted by this manganese ion. Okay, manganese ion tu dia akan accept electron to form manganese 2 plus. Okay, so that is why what we call a transfer of electron. Ada loss of electron, ada gain. There is a gain of electron. So that is the redox reaction. Okay, so how do we combine these two half equation to make it as ionic equation? So you have to form the full ionic equation. So as you can see here, okay, one iron 2 plus will release 1 electron, but one manganese ion will accept 5 electrons. So there is 5 electron here. So we cannot combine the half equation if you have different number of electron. Kita kena tukar, we have to change so that the electron is the same. The total number of electron for both half equation is the same. So what we do is we will multiply the first half equation, the one that have last electron, with 5. Okay, why 5? Because we want to achieve the 5 electrons. So when I times this half equation with 5, so I will get 5 Fe2 plus that will, okay, form 5 Fe3 plus and 5 electron. So during this reaction, when I have 5 iron 2 plus, it will release 5 electron, and the 5 electron will be transferred through the external circuit, okay, dekat wire tu. Okay, dia akan go through the galvanometer, deflect the galvanometer and come to electrode Y electrode. The manganese ion will accept this 5 electron and form manganese ion. Okay, so in this reaction, how do we balance ataupun form the ionic equation. So we'll put this 5 electron aside. So we'll cancel this 5 electron aside, and we will combine this equation together. Okay, siapa dengan siapa? Okay, the reactant dengan reactant, product dengan product. So that is the separation lah. Okay, so kita salin je, copy saja semula, Fe2 plus MnO4 minus plus 8H plus produce 5 Fe3 plus Mn2 plus 8H2O. Okay, so this is what we call, okay, the ionic equation for this reaction. Okay, take some time, okay, to look at this ionic equation. Okay, during this reaction, so as you can see, there is loss of electron and also gain of electron. Okay, so loss of electron is oxidation. Okay, loss of electron, or oxidation is loss of electron. So ada oxidation reaction, and you also have means reduction is gain of electron. Okay, so substance that undergo oxidation, it is a reducing agent. Substance that undergoes reduction is the oxidizing agent. Okay, now for this reaction, okay, as you can see here, after the electron being transferred to Y electrode, so the manganate ion will accept the electron here. So the electron being accepted at the Y electrode. So the change of color, okay, at the Y electrode here, the color will change from the purple color solution to colorless solution. Okay, why? Because, okay, this ion, okay, manganate ion is purple color solution. Okay, but manganese 2 plus ion is colorless. Okay, so it will change from purple color solution to colorless solution. Okay, as a conclusion, so you will see that this equation here is called ionic equation. So this is called ionic equation. Okay, so ionic equation is referring to combination of both half equation at electrode X and electrode Y, where the oxidation and reduction happen during the transfer of electron. Okay, thank you for listening to my video and watching my video. I know that maybe some of you still have difficulties to understand this example, but if you try out some of the oxidizing agent and reducing agent in the same tube, you can get the idea of transfer of electron at a distance. Okay, so just stay put and see you in the next video. Have a nice day. Thank you.